Hello, thank you so much for your time and thanks for the click. My name is Darlin Fee. Today we are starting an exciting episode, and this is going to be very simple for all of us. If this is the first time you are seeing this channel, we want to encourage you to subscribe so that all subsequent videos that we upload on this platform, you will be able to get notification. Now we are going to meet this kind of integration more. It doesn't matter the level, whether you are in high school, you are in college, you are in engineering, you are going to meet a lot of this. So by definition, the integral of 1 over x squared plus a squared dx. Now notice that this x squared here is a perfect square, and then the a squared here too is a perfect square. So by standard integration, the integral of this is going to give you 1 over a tan inverse of brackets x over a plus c. Let's explain this further. Now, why do you see this? It's quite simple. Now, as for this one, is constant, so it must always happen. It doesn't matter which number is here. Whether you have 4, you have 5, you have 6, this it will still remain as 1 because it is constant. And then the a here refers to the number here. So for example, here we have a squared. So it is this a that was picked, and then we have it here. Then the tan inverse is also a constant thing. Then we have x over a, that is the variable here divided by the variable here. Remember, we don't consider the exponents, but the standard definition states that the integral of 1 over x squared plus a squared dx. Notice that provided you are having a perfect square here and a perfect square here, this is going to be the integral. Now we have plus c because this is an indefinite integral. So for indefinite integral, you need to introduce a constant. Now for better understanding of this, let's have some example. So we have evaluate the integral of 1 over x squared plus 4 dx. So when you look at the standard one, this is a perfect square. Now here too we have x squared, also a perfect square. Then you compare to the standard one, we have a squared, which is a perfect square. That means in order for us to solve this, we need to be able to break the 4 into a perfect square. And you know that 2 times 2 will give us 4, which means this is the same as 2 squared. So when you come down, you are having the integral of 1 over x squared plus 4 dx is equal to, now this where we have broken it down. And so if you look at it carefully, the 4 now has become 2 to the power 2. Now notice that from the definition, this x is what we see here in green, and then the a is what we see here in blue. That's the a. Then by the definition of this integration, we are having 1 over a, where I said the 1 is a constant. So that 1 is what we have here. And then when it comes to this question, the place of a, we have 2 here. And so instead of this a, I have 2 here. Please note, this 2 does not refer to the exponents. The 2 refers to the base. And so we have 2 here. And then tan inverse as we have in the standard one. Then when we come to the standard one, we have x over a. So remember, the x is the first perfect square, the base. And then the a is the second perfect square, the base. And so when we come to this, the first perfect square, the base is x. So we have x at the top. And then the second perfect square, the base is 2. So we have 2 also at the down. And then of course, because the integral is an indefinite integral, you need to introduce your constants. And that is how simple it is to use this standard integral. So for our example 2, we have evaluate the integral of 2 over x squared plus 9 dx. Remember, by the standard definition, 1 over x squared plus a squared, meaning this should be a perfect square and then this must also be a perfect square. So whatever you were given in the question, make sure you break them down into perfect squares. So as for the x square, is already in perfect square, and then we know 9 is also a perfect square. But when we break 9 down to have an exponent, we are actually getting 3 to the power 2. And so this is the same as what we have here. X squared, we have it here, x squared in green. And then the 9, when you break it down, you are getting 3 to the power 2. So remember, we have perfect square here, and then we have perfect square here. And then let's go. Now you saw from the beginning that this part was 1, but this case we are having 2, not 1. Now anytime you are integrating this standard, all you do is that you bring the 2 down here. And so if you look at it, now you forget about the 2 for the time being, and then let's concentrate on what we are doing. So how do we do it? So I'm saying that for now, forget about the red one, okay? And then let's use the standard integration. So let's see. By the standard definition, we have 1 over a, and then the a here in this example 2 is 3. So we are going to have 1 over 3. And then we have tan inverse. So tan inverse, the tan inverse is here. Then the standard definition says we have x over a. Remember, the x is the first perfect square, the base of it. And then the a is the base of the second perfect square. So here, the first perfect square is x. The base of the first perfect square is x. So that comes up. So we have it here, x squared. And then the base of the second perfect square, that is 3. So we have it also here as 3. So we have it here. So that explains why. So this green x is what you see here, the green x. And then the base 3, this 3 in blue, is what you see here as 3 in blue. Now the question is, where from these two? What it simply means is that whatever number you have here is going to multiply what you get. So let's come to the standard example. Assuming this one were to be 4, then this 4 would have multiplied the 1 over a. If this one were to be 6, then this 6 would have multiplied 1 over a. So in the case of this example, we have 2. That means the 2 is going to multiply the 1 over 3. So we have 2 times 1 over 3. And then when we strike it out, you see that 2 times 1 will give us 2. We have it here. And then divided by 3. So we have it here. That means when we simplify this, we are actually getting 2 over 3 tan inverse of x over 3 plus c. Now look at the colors very well. These 2 is the same 2 you see here. And this same 2 multiply this 1, and then we are getting this 2. And then for the green here, which is the first base of this perfect square, we have it here. And then the 3 in blue, which is the second base of the perfect square, we have it here. So this is how easy it is if you are dealing with the standard indefinite integral.